Okay, let's rinse and repeat. So let's do another one while we got good momentum here. So I'm going to focus on the left side. I'm going to convert that into an auxiliary equation and then write my complementary solution based on the types of solution I find for my auxiliary equation. So that's m squared minus 2m minus 3 equals 0. And I believe that's minus 3 and plus 1. So m would be 3 and negative 1, which would translate to a general solution of c1 e to the negative x plus c2 e to the 3x. Okay, so in this next case on the right side, what do we have? And actually, I don't want to color code the whole thing. I'm going to break this up into really two different types of equations because our particular solution for those types are going to be some sort of linear format and then some sort of exponential format. So there's a couple of connections we can kind of make here. So my particular is going to look like some sort of a linear equation plus some sort of exponential equation. And in particular, that 4x minus 5 tells me it's going to look something like ax plus b. And then that exponential, if we think about what happens when I start taking derivatives of these things, because I'm going to have to do a derivative and then a second derivative, that means the exponential is going to have some sort of x e to the 2x and some e to the 2x as a component of those further derivatives. So writing out kind of that thinking as to what the particular solution is going to look like, it's going to look like some general format of ax plus b plus some c x e to the 2x plus some I'm going to go with e. Why not? E to the 2x on that. Okay, so then I need to find my first derivative. So that's just a plus c, and I'm going to, since we're doing product rule for that, that's going to be x times 2 e to the 2x plus e to the 2x plus e times 2 e to the 2x. Well, isn't that lovely? Okay. And then my y double, so a goes away, and I still have that c out front. So now I have kind of a repeat. So the derivative of x times 2 e to the 2x is x times 2 times 2 e to the 2x plus 2 e to the 2x times 1 plus, and the derivative of e to the 2x would be 2 e to the 2x plus, all of that's times c, plus, it looks like e to the 4 e to the 2x. Okay, so I can take the time and I can expand this whole out and I can make it nice and pretty, but let's be perfectly honest here. What am I going to have to do with all this stuff? So I'm referring back to the yellow function here, so y double minus 2y prime minus 3y. So I'm going to have to take this expression up here. Let's see. So this thing, and this thing. And I only need one of it. I need negative 2 of it. I need negative 3 of it. Okay. So let's see if I can do some nice pretty distributing, and I think that would be worth the time to write out. Okay, so I kind of sped up the distributing component. I'm kind of point out what I did here. So I did let's see, so I kept the original, this one, so this, let's go back to color coding. So this row is this row, and then this row is that row, and then this row is that row. So I just did the distributing part for you, so you don't have to watch me do a bunch of distributing. And now I want to partner up like terms. So I'm looking for anything that has an x associated with it. So I see there is an x right here, and then that is it. Okay, so that tells me that negative 3a has to equal the 4 in front of the 4x. So that has to equal 4. Okay, so then I want to look for any constants. I'm having fun with my pen here, so look for anything that doesn't have a variable connected to it in that mess, and that looks like it. So negative 2a minus 3b has to equal the negative 5. Then I want to look for any x e to the 2x's. So x e to the 2x. So I got one here. There's another one. And there's another one. Okay, so I have a positive 4, a negative 4, and a minus 3. Okay, so that means I'm going to have negative 3c equal to the coefficient in the original, which was 6. Okay, and then anything left over, let's see, so that gives me, I don't know if the circling is helping or not, so I got a positive 2, a positive 2, a minus 2, so that's going to give me a positive 2c. And go back to rainbow again. Alright, so here's all my E stuff. So I got a positive 4, a negative 4, so that essentially cancels that out. And then a negative 3. So 2c minus 3e. And in the original, I didn't have a e to the 2x. I had an x e to the 2x, but I didn't have any e to the 2x, so that's going to be 0 for that. Okay. So now I just need to go back and solve for A, B, C, and E. Alright, so A is negative 4/3. This is 2 times negative 4/3 minus 3b equals negative 5. So that's 8/3 minus 3b. Oh, run out of space down here, so I'm going to scroll a little tiny bit. Not get too excited about my scrolling there. So I should get B is going to equal 23/9. C is negative 2. So 2 times negative 2 minus 3 times E equals 0. So that's negative 3 should equal 4. So E should be negative 4/3. Okay, so let's put that part together with the other part in our general format. All right, so we have y equals c1 e to the negative x plus c2 e to the 3x minus 4/3 x plus 23/9 minus 2x. Actually, I'm going to group those guys together. So minus 2x plus 4/3 e to the 2x. All right, there we go.